5.5. Okay, in this lesson we are going to start solving quadratic equations by completing the square. Okay, and then we're going to use that same process of completing the square to write a quadratic equation into vertex form as well. So up to this point we have really three methods of solving. We have solving by graphing. Okay, so we find the solutions or zeros or roots, any one of those words, again, meaning the solution to a quadratic. We find that by the x-intercept on our graph. Okay, and then we have solving by square rooting, okay, where we isolate the squared term, square root both sides. And then finally we have solving by factoring, which is always going to be your first method you want to try when you do this, and given any possible way of solving. Okay, but today again, completing the square. This is kind of the most, I don't want to say useless, but useless methods. But it is another method. Some people do like it, but it is another way to solve a quadratic, just not one that you typically will use. Okay, so we have our quadratic, ax squared plus bx plus c. And since we're going to be solving, it's set equal to 0. And what we need to do in order to complete the square, okay, first need to write the equation so that c is on the right side of the equal sign. Okay, so all you have, again, this is our quadratic term, and this is our linear term. Okay, you want the quadratic term and the linear term on the left side, and then the constant on the right side. Okay, and again, the c is your constant. Then from there, what you need to do is make sure that your a value, so the coefficient with your quadratic term, is 1. Okay, and then once you have that, you're going to take half of that b value and square it. And you're going to have to add it to both sides. Again, we got to, our rule of equality, okay? Whatever you add to the left side, you have to add to the right side. And then from there, once you add that value on the left side where you have the quadratic and the linear term, now you have a constant term as well. That's going to be a perfect square. Okay, that's your actual step of completing this square. And then from there, we can square up both sides of the equation. So here is our first one. So again, the first step, we said we were going to bring the c value to the right side. So when we do that, add 8 to both sides. So then we're going to have x squared plus 6x, okay? And then if you remember, in one of the next steps, we're going to be adding something there to both sides. So I always like to leave that space there. Okay, is equal to 8. And again, we're adding it to both sides. That is one step a lot of people forget. They just add it to the one side. Okay, so then from there, you make sure that the a value is 1. In this case, the a value is 1 already, so we're good there. Then from there, again, the b value at this point, when the a is 1, is 6. So half of 6, that's saying 6 divided by 2, and we're squaring that. So that's saying 3 squared, or 9. So 9 is the value we're going to add to both sides. Now, at this point, okay, that left side, we can write as a perfect square. Okay, as a perfect square, we're saying we can do some binomial squared. All it is really, all we're going to do is factor this. Okay. So when you factor this, left side's going to equal 17. It's going to be x plus 3, x plus 3. Okay, it's two of the same terms. So again, we can write that as x plus 3 squared. It's a perfect square now. So now at this point, okay, this is kind of like we have when we are solving by square rooting, because that's the exact, it's really we're completing the square so we can solve by square rooting. Because now I want to get rid of that perfect square, and I'm left with x plus 3 on the left side is equal to plus or minus the square root of 17, which does not simplify. Okay, but now at this point, okay, don't forget about that plus or minus. Okay, since we're in the process of solving, we need to do plus or minus. Finally, bring that negative 3 over. So x is equal to negative 3 plus or minus the square root of 17. Okay, so that was the first one for completing the square. Moving on now. Okay, so we have, again, a value is 1. You can really take care of that, making sure that a value is 1 right away. So here we're good. So what we're going to do is we're going to bring that constant over. X squared minus 3x plus something is equal to that 4 plus something. And again, half of b squared, our b value in this case is negative 3 over 2 squared, which is going to give us 9/4. Okay, so we're adding 9/4 to both sides. Now, when we actually complete the square now, okay, we have completed the square, but when we write this as a perfect square, okay, it's always going to be x, okay, so because we should have made that a value 1, and then we're looking at that half of b, okay. That is what's going to be the second part of your binomial every single time, okay. So again, those two things, half of b, or b over 2, is always going to be the x minus, x plus, whatever. Okay, so and then when we simplify that right side, okay, 9/4 plus 4, 9/4 plus 4 over 1, so we'd have to get a common denominator by multiplying both top and bottom by 4, 25/4. So now we're at the step where we need to square root both sides. Okay, so then we're left with x minus 3/2 is equal to plus or minus, okay, square root of 25/4. So again, if we break that up, let's go up here and we'll simplify that. Square root of 25/4. We'd split that up, square root of 25 over square root of 4. Square root of 25 is 5, square root of 4 is 2. So that's 5/2. And then finally adding that over, x is equal to 3/2 plus or minus 5/2. Okay, and those are two, not whole numbers, but integers that we can, not integers either, but we can add those up. 3/2 plus 5/2, that's 8/2, or 4. 3/2 minus 5/2, that's negative 2/2, which is negative 1. So we got an answer of x is equal to 4, x is equal to negative 1. Alrighty. So the next one, a little more complicated due to the fact that our a value is not 1. Okay, again, I said we could take care of that a value being 1 right away, so let's go ahead and do that. In order to make the a value 1, we're going to have to divide by 5. So we're going to go to every single term and divide by 5. So if I got that, I got x squared plus 4 equals 2x. Now I need to get my quadratic and linear term to one side. So x squared is on the left side. If I bring that 2x over, that's going to be minus 2x. We're going to add something. We're not sure what yet. We're going to bring that one over. It's going to be negative 4. And we're going to add that something to that side as well. Okay. So again, half of b squared. B is negative 2 over 2, which would be 1 squared or just 1. Okay, so and then again, this is just saying negative 1 squared. So when I write my perfect square, x minus 1, and again, those things, that half of b, those two things will line up every single time. Okay, so then finally square root, we get x minus 1 on this side is equal to plus or minus the square root of negative 3. Okay, so again, we can't have a negative under a square root. And we have to bring that 1 over. So add 1, x is equal to 1 plus or minus. To take that out, it becomes I root 3. Okay, so there is that one. A little more difficult due to the fact that we had to get that a value to be 1. That is a step that a lot of people forget. Okay, so you need to make sure the a value is 1 before we complete the square. All right, so for the next one, same idea. You need to get that a value to be 1. So we need to divide everything by 3. When we do that, end up with x squared plus 3x minus 3 equals 0. Okay, bringing that constant over, x squared plus 3x. Eventually, we're going to add something is equal to 3 plus something. Okay, half of b over 2 squared. So 3 halves squared, or 9/4. Okay, so we're adding 9/4 to both sides. Okay, so and then again, when I write my perfect square now, x, looking here, plus 3 halves is equal to, and let's do 3 plus 9/4. Okay, multiply top and bottom by 4 on that 3 over 1. So we got 12 over 1 plus 9/4, or sorry, 12/4 plus 9/4, or 21/4. Okay, so then we got 21/4 on this side. We're to the point of square rooting. So x plus 3 halves on this side is equal to plus or minus. And let's go ahead, let's split it up right away. 21, square root of 21 over square root of 4. Okay, subtracting the 3 halves over, we get negative 3 halves, plus or minus square root of 21 over 2, because that's square root of 4. We'll simplify to 2. Okay, so that is the method of completing the square to solve. Now again, we can use that completing the square to help us write an equation in vertex form as well. Okay, so if you've noticed, okay, whenever we complete the square, it always kind of looks like vertex form because we get that quantity squared, okay, where we can get h and k. So if we go ahead and we do number 1, okay, now the one thing here is it's just going to be y instead of 0 now instead, okay, because typically when you solve, you have it set equal to 0. Since we want to keep it as a function, okay, just in vertex form, we're going to leave it as y. So I'm going to, again, we still get the c value over. So we're going to have y minus 5 is equal to x squared plus 8x. Okay, so we're going to add something to both sides. Okay, we're still taking half of that b value, so 8 over 2 squared, which is 4 squared, or 16. So we're adding 16 to both sides, so now we have y plus 11, when I do negative 5 plus 16, is equal to x plus 4 squared. Now, another thing that I remembered, a lot of people forget this square. It is very important that you write it as square, because if it's not squared, then it is not a quadratic. Now you have a linear function, okay? Now the last step in order to get into vertex form is to get it so it says y equals. Okay, so subtracting that 11 over, subtract the 11 over, y is equal to x plus 4 squared minus 11. All right, so that's a way we can use the completing the square to write into vertex form. Now there is another way, which I actually think is quite a bit easier. Okay, so you can complete the square in order to write it in vertex form, or you can take the equation, find the vertex, okay, in standard form. The x coordinate is negative b over 2a, so in this case negative 6 over 2 times negative 3, which would be negative 6 over negative 6, or 1. Okay, so the vertex here would be 1. Plugging it in, okay, so plugging it in, we're going to have negative 3 times 1 plus 6 times 1 minus 8. So it'd be negative 3 plus 6 minus 8, which will be negative 5. Okay, now when you are writing this in vertex form, okay, the a value never changes no matter what form you're in. Okay, so the a value in this case is negative 3, so that would have to come first. Okay, so and if you remember, y is equal to a times x minus h squared plus k. Here's my h, there's my k. So x minus 1 squared plus k, so minus 5. There we have it in vertex form. And we did forget to identify the vertex over here. Okay, opposite of what we see. So negative 4, negative 11. All right, we're not going to worry about that last one. But when it comes to writing a quadratic function into vertex form, you have those two routes. Okay, you can use completing the square, or you can just find the vertex and then write it into that vertex form. Okay, using that general equation for vertex form. All right, so that is 5.5, completing the square. Your homework includes 5.5, page 286. Okay, so make sure we go in there and get that completed. Other than that, have a good day.